back, students. So in this section we are going to solve the third problem here. Until now we have solved two problems, and here now we are going to solve the third problem. That is example 3. Construct the dual of the LPP. So problem is max z is equal to 3x1 plus 10x2 plus 2x3 subjected to constraints subjected to constraints 2x1 plus 3x2 plus 2x3 is less than or equal to 7, whereas 3x1 minus 2x2 plus 4x3 is equal to 3. Fine. So solve pretty much requirement. And x1 is greater than or equal to 0, comma x2 is greater than or equal to 0, comma x3 is greater than or equal to 0. Right? So we have got three constraints here, but what happens? The given LPP is not in the canonical form. Why it is not in the canonical form? Because the constraints are, one of the constraints is subjected to equal to. Right? One of the constraints is subjected to equal to. And what happens? The objective function is to be maximized. So if at all the objective function is to be maximized, the constraint has to be less than or equal to. Fine? If at all the objective function has to be maximized, the constraint should be what? Less than or equal to. But it is not in this case. Fine? So what we do here? Solution. As the given LPP is of maximization all the constraints should be of less than or equal to type, but the second constraint, what? The second constraint. What is the second constraint? That is 3x1 minus 2x2 plus 4x3 is equal to 3. Fine, 3. But the second constraint is not less than or equal to 5. Fine. So how to do this one? It is equal to. So the second constraint can be expressed as a pair of inequality, that is 3x1 minus 2x2 plus 4x3 is less than or equal to 2, less than or equal to 3, and 3x1 minus 2x2 plus 4x3 is greater than or equal to 3. Fine. So I have expressed it in two formulas. This is one. Another one is this. Two pairs. So can be expressed in two pairs. Fine. So or I can write like this. It is 3x1 minus 2x2 plus 4x3 is less than or equal to 3, and minus 3x1 plus 2x2 minus 4x3 less than or equal to 3. Fine. Fine. Is it okay? Let y1 comma y2 dash comma y2 double dash be the associated non negative dual variables. Then the dual problem is, so it is maximization. Let me write minimization, min z dash, because if the primal is max, then it will become min. So it is 7y1, it is 7y1 plus 3 into, what happens here, 3 into, it is y2 dash minus y2 double dash. What it is? 3 into y2 dash minus y2 double dash, subjected to constraints. It is 2y1, or it is 2y1 plus 3 into y2 dash minus y2 double dash greater than or equal to 3. Fine? Greater than or equal to 3. This 3. Next comes, it is 3y1, that is 3y1 minus 2 into y2 dash minus y2 double dash greater than or equal to 10. So this is 10. And the last thing, it is 2y1 plus 4 into y2 dash minus y2 double dash, that is greater than or equal to 2, where y1 comma y2 dash comma y2 double dash are greater than or equal to 0. Fine. Substituting y2 dash minus y2 double dash is equal to y2, where y2 is, so where y2 is unrestricted in sign, y2 is unrestricted in sign, where y2 is unrestricted in sign, then the dual problems becomes, then problem becomes, so substitute y2 minus, substitute y2 dash minus y2 double dash is equal to y2, then what it becomes, that is min z dash is equal to 7y1 plus 3y2 subjected to constraints what it is, 2y1 plus 3y2 less than or equal to 3, followed by it is 3y1 minus 2y2 which is less than or equal to 10, that is 2y1 plus 4y2 less than or equal to 2, where y1 comma y2 are greater than or equal to 0. Fine. So this is how from primal to dual is done here. Okay. So please follow this one. So for your clarity, let me repeat this once again. So this is what the given primal. Now the primal is not in the canonical form. Why it is not in canonical form? Because objective function is to be maximized, but the constraints, all the constraints have to be of type less than or equal to, but one constraint is equal to. So we need to convert that equation into less than or equal to type. So to do that, what? The second equation can be expressed in the form, that is 3x1 minus 2x2 plus 4x3 is less than or equal to 3 and greater than or equal to 3. But I want to convert this equation to the less than or equal to. Fine. So the now is the equation is converted here. But what happens here? There are two equations. But what I do here, that I will take y1 comma y2 dash comma y2 double dash are the associated non-negative dual variables. Fine. So then the dual problems becomes mean z dash. Z dash is nothing but dual. So 7y1 plus 3 bracket y2 dash minus y2 double dash. So I have written all of this. If I want to convert substituting y2 dash minus y2 double dash is equal to y2, then the problem will become this. So this is what the primal. This is what the dual, and this is primal. Fine. Thank you.